Hello friends, my name is Dr. Abhilasha. This is a video presentation on my machine learning project using Python. For doing this project, first of all, I have installed Anaconda and Jupyter Notebook. Then through Jupyter Notebook, I have designed um, a machine learning project using the previous data on automobile dataset. For doing this project, first I have imported all the libraries, Python libraries which are required for doing this project. Pandas for treating with data frames, NumPy, Seaborn, and Matplotlib, etc. Then I have created a CSV file for automobile data, and then as it is a CSV file, I have used pt dot read function and read underscore CSV to read this data set. Now this is stored as a data frame in variable auto. Then I have used auto head to look at all the columns which are there in this database. Okay, there are sorry, there are 26 columns, that is, you can say there are 26 features for this data set, and there's one price feature. So therefore, we define a problem to find the price of a automobile depending on these feature set. Okay, and in this, to describe the database, we use the function describe, which describes the number of rows, which is 201 rows in this database, mean for each column, standard deviation, minimum value for each column, and maximum, then 25 percentile, 50 percentile, and 75 percentile, and it gives the maximum value. Then I have checked the values, is there data set, is there any missing value. For checking the missing value, I used is null function. As all the values in this database are false, that means all the values are available, there is no missing data. Therefore, we can treat this data, it is prepared for using machine learning. Otherwise, if there is a missing data, then we have to use some other methods to prepare this table. Um, then as our target is to find for the given set of features, we can find the uh, price of the automobile. Therefore, we place this as target, price column of this data as a target, and next is we find the maximum target price and minimum target price. Okay, then to find, as we want to apply the linear regression for finding the price of automobile. Therefore, we find with which feature the price of automobile is maximum correlated. For doing this, we find the correlation, Pearson correlation with each and every you can say feature, Then from the correlation matrix, we find there is maximum feature with of price with engine size. To make it sure, we plot a scatter plot among these data points and price value. And by running this, we came here that there is a uh, better relation, a linear relation between this engine size and the price. Okay, therefore we have taken engine size as independent variable and price as a dependent variable. Okay, other method for finding this is you can find the correlation of price with the all columns instead of finding that you will make it with each and every column. Okay, and this is another method where we are finding the correlation of price with each and every feature, and we sort it. After sorting it, we find that again we were finding that the engine size has maximum correlation with the price. Therefore we take y uh, x as engine size, which is we consider as independent variable, and price is dependent variable. Okay, and we store uh, engine size values in variable x and price values in variable y. Okay, then before applying on here on linear regression, we uh, normalize the data uh, into range 0 to 1 using min max scaler. Okay, for doing this, we use min max scaler, then we reshape it, and with these steps we normalize the data. Okay, then for finding the mean square error, we write uh, error 1 function where m is the slope of linear line and c is the y-intercept, and here we find the size of data set data entries. Okay, and we find and y target y actual y obtained minus target value whole square, and we find the sum of all multiplied by 1 by 2 n. Then we split the data into test and training data by using the train, test and split function. Okay, and the percentage size for test data, we have taken 20% of the data is taken as test data and rest of data is taken as train data. Then for finding for updating the value of m and c continuously depending on the error, we write a function update where we are passing the slope, y value, and c initial c value, target and learning rate. According to this, we change the value of m and c by finding gradient m and gradient c. Okay, then we write a gradient descendant function for finding the exact value of m and c, and we repeat this process. Updating of m and c are repeated till the error is less than the error threshold. Okay, then by writing the gradient function, we have initialized the value of MC and learning rate and number of iterations. We have taken initial value of M as 0.9 and C intercept as Y. Learning rate is taken as 0.001. Number of iterations as 250 and error threshold is taken as 0.001. Okay, and then we apply the gradient descendant function to calculate the value of MC, and Another is to calculate obtain how the value of M and C is going on changing. Then we plot the original X training data and Y training data. These dots are showing the training data sample points. Then we plot a regression line using newly calculated M and C, which is shown here with red. Okay, then from this we show that it is a good fit over here. Then to plot how error going on decreasing, or what the behavior of error while finding this regression line, we plot the number of iteration and error at each iteration. From this plot we have seen that the error is going on decreasing, and up to 250 it is just going to be straight and remain unchanged after that. Then we find, now we test it on test data. We find a predicted value for test data, then mean square error for predicted value, which comes out to be 0.0071, which is less. Okay, then we plot the predicted and target value on the normalized scales. We have seen this line is again a good fit for the given data. Okay, then we see the first 20 columns how actually target and predicted is changed. There's very less difference between the actual and the target. Okay, then to get these values on the original scale, we reshape these values and take the inverse transform of these values so that we get the scale values. Okay, then again we stored this as a data frame, and we have tested, to test it we print the data. Thank you.